Next topic is numerical solution of algebraic and transcendental equations. This topic deals with two numerical methods of obtaining approximate real roots of the given equation. First, let us see what do we mean by algebraic equations. Equations involving algebraic quantities like x, x square, x cube and so on. For example, these are called as algebraic equations. Transcendental equations, equations that involve non-algebraic quantities like e to the power x, log x, sin x, tan x, etc. For example, these things are called as transcendental equations. Here we discuss two numerical iterative methods to find the roots. First one is the Regula-Falsi method, then Newton-Raphson method. Regula-Falsi method is also called as method of false position. Let the given equation be f of x is equal to 0 that possess only one real root in the interval a comma b. And let us suppose that f of a is less than 0 and f of b is greater than 0. That means the values of a and b should be in such a way that f of a should be less than 0 and f of b should be greater than 0. Then how do we find the root, a real root, which is lying between a and b? So what we understood, first thing is we need to find the interval a comma b where the root lies. Then we apply this formula to find that real root in between a and b. Then we go on improving this root iteratively. Now here we have an important remark. If a comma b are close enough, we can obtain the approximate root to the desired accuracy quickly. So let us see a problem. Use Regula-Falsi method to find a real root of the equation. Here is the equation. Correct to 3 decimal places. Let us first see the overview of this problem. We take the given equation as f of x, that is equal to x cube minus 2x minus 5. Now we are in search of a comma b, for which f of a is negative and f of b is positive. For that we need to go on putting the values of x randomly. First let us take x as 0 and put this value of x in the function. Now let us find f of 0. Put x is equal to 0 everywhere in the RHS of f of x. You will get minus 5. You get minus 5 from this if you put x is equal to 0. Yes, what is minus 5? It is negative, that is less than 0. So it is less than 0. Now let us go for next value of x. Let us take x as 1 now. Put x is equal to 1 in the function now. F of 1, you will get a minus 6 when you put x is equal to 1 in this. You will get a minus 6. See, this is again minus 6 is also negative. We should continue the process till you get a positive value, because one should be negative and another should be positive. This is also negative. Now let us take x equal to 2. We have taken x as 2. F of 2. If you find f of 2, if you place x is equal to 2 in this, you will get minus 1. See, again you got negative only. That means we need to take another value of x and check. Let us take 3 and find f of 3. So f of 3, if you put x is equal to 3 in this, what you get as this, you get 16. Very good. Now you got f of 3 as positive and f of 2 as negative. So we got one negative and another positive. That shows that this is our a, 2 is our a, and the value of b is 3. So our root lies between 2 comma 3. Our root lies between 2 comma 3. Take these values of x as the interval. Our root is here, from here to here. Our root is lying in between somewhere here, where that is what we are going to find it now. So here we are we have written less than 0. That means the value of the function at 2, at x is equal to 2, is less than 0, and value of the function is greater than 0 at 3. That's what we have found there. If you see the remark which we have mentioned earlier, see the gap between 2 and 3 is not small. We need to make it small. So that's why we need to find one more value in between and take that as a comma b. Then we can apply the formula for x, but not now. How do we locate one more value in between here without using the formula? See, here is observation. Here f of 2 value, that is minus 1, is very near to 0 than 16. 16 is far away from 0, but minus 1 is not far away, it is closer than 16. So therefore we can conclude that our root lies near to 0, very near to 0. So by that concluding point, we can take one more value, say 2.1, which is near to 2 and between 2 comma 3. We cannot take this value as 1.9, because that will go beyond outside the range. So we need to take 2.1, which is very near to 2 and inside 2 comma 3, and we will find f of 2.1 now. Let us find f of 2.1 and check whether it is positive or negative. So f of 2.1, how do we find f of 2.1? Just put 2.1 in the place of x in the function. You will get 2.1 value, that is 0.061, which is greater than 0. So we got f of 2.1 value is greater than 0. Now let us locate this 2.1 on this line. Yes, 2.1 here we have written. in between 2 and 3, and the function value at this point is greater than 0. So our range should have the opposite values. Here it is less than 0, here it is greater than 0, and this is also greater than 0. So we can neglect this value and we can take the smaller range, so that it becomes easier for us to apply the formulas with the smaller range. So here are the two opposite values, functional values. Now let us go for x formula and apply this formula here to find one more root in between these two. So we can conclude that our root lies between 2 comma 2.1. So we have neglected 3 and we have taken completely 2 and 2.1 here. We have neglected 3. Let us apply the formula which we have already seen to find a new root between 2 and 2.1. What is A? A is 2, and what is B? B is 2.1. F of B means f of 2.1, which is here, the value we know. F of A means f of 2. F of 2 is already here, which we have found. Apply these quantities in the formula, you will get the value of x1 as 2.0942. Then apply this x1 in the function and check whether it is positive or negative. First we locate this value in between 2 and 2.1, somewhere here, and check the sign of the function whether it is positive or negative here. Take the value, put in the function. Yes, we have put in the function, and simplify this function value, get this answer minus 0.00392, which is negative. So we have written less than 0 here. Yes, we have located. Now what we do, we have to neglect one value and we have to take only two values among these three values. So which should be neglected? Yes, this 2, for which a function value is negative, because we got one new value here, for which the function value is negative, so that we can have the range even smaller. Yes, we got the range which is even smaller than the previous. Now again we apply the same formula in between 2.0942 and 2.1 to get one more root, improved root, that is called as x2. So we can conclude that our root lies between these two new values. Now apply the formula again. Take this as A, take this as B, and f of B is f of 2.1. Where is f of 2.1? We have found f of 2.1 here. And what is f of A? F of A is f of 2.042, which is here. We have all the values and put all the values in the formula to get new root, improved root, which is this. So this is the new root which is lying between these two values here. We have located that. Now you can observe the previous root and the new root are almost very near, very near. See, 2.0942 and 2.09455. So we can stop our process and we can conclude this is the required real root of the given equation. So this is the overview of the problem. We are going to see the detailed solution now.